Hey, I'm Mike. Welcome to Need It Make It. I thought I was done with bed slingers. They're slow, they have lots of artifacts, they have ringing, they have blobbing, they have stringing, at least with my Bowden setup. They're also open, so they needed a separate enclosure to print certain materials, and they collect a lot of dust, at least they do in my workshop. But I've seen a bit of a resurgence in bed slingers lately, thanks in part I think to better software that they're using and also just better design decisions. So I thought it was worth having another look to see if they are any good, because if they are, they're usually quite a bit cheaper than the Core XY alternatives. So let's have a look and run some tests as well to see how the next generation of bed slinger actually performs. So stick around. Creality has sent me this printer to test out, which is the Ender 3 version 3 model KE. I think for the sake of this video, I'm just going to call it the Ender KE or the KE. So testing is exactly what I want to do today, and that means showing the good, showing the bad, and possibly some recommendations as well. I don't really want to talk about every little tiny change. I really like to focus on only what I believe are the most important ones. This printer runs Clipper, which means that it has the ability to do things that the older style of printer just cannot do. Creality does make something called the Sonic Pad, which is meant to upgrade older printers to have a similar capability, but this printer has it all in one nice package. And after receiving it, I ran a firmware update, and the printer now allows us to root it, which means we can also use a different slicer like Orca or Prusa slicer as well. And that's nice because I have a lot of different printers and I just like to use the same slicer for each of them. So to get better results with a printer like this, there is a separate accelerometer that can be mounted, and then the software can run vibration compensation for this printer. But unfortunately, I don't have one. They are pretty cheap, but I think they should probably come standard with an accelerometer as well, since it's just a tiny part and it could be easily integrated into the design. Next up is direct drive. Normally we didn't see too much direct drive on a bed slinger, but this tech has improved quite a bit, and the extruders are smaller. They're also lighter. They're just altogether better than they used to be. Direct drive is a great addition because it allows us to print flexibles way more easily. It also simplifies the process a bit. Lots of times Bowden setups gave us some trouble and added that little extra need to fine tune for retractions. With direct drive, it's far less of a problem. Also, changing filament color mid-print is so much easier on a direct drive printer. Next up is the heater or nozzle setup on this printer. It heats up way quicker. It can maintain temperature even at high speed. They say 500 millimeters per second. I've tested it and I've maxed out pretty close to that, at least with my filament. So it is possible with the right high-speed filament to get to that kind of speed. Now, I'm not recommending that you run your printer at that speed because your quality will suffer a little bit, but at least there is the potential. If you're in a bit of a bind and you need to get something cranked out, you definitely have the ability to do that. Creality's newer printers use a ceramic heater, and this one does as well. And the printer uses the same nozzles as the K1 or K1 Max. They're like a volcano style nozzle, which has a longer heating zone. And that means that if you want to print abrasive filaments, you can just switch out the nozzle for a hardened steel one. And even if you have different printers that are all Creality printers, you can swap that nozzle between them. We also have dual part fans, so with faster printing speeds comes problems with cooling. Now this printer being open as it currently is, isn't as much of an issue, but dual fans here will definitely help to cool those overhangs and prevent them from curling up on you. We're seeing linear rails on the x-axis. Linear rails are normally very precise and long wearing. It's also a good addition for really good results. On the y-axis, we're seeing linear bearings instead of linear rails. I like this addition, especially compared to the original design where the bearing surface was just more central. I see that there is a little bit of wobble with this setup though, so the bearings are either a little bit too large or the rods are a little bit too small. I've taken it apart and tried to align them a little bit better, and that helped quite a bit actually. It's an easy fix, but maybe Creality can fix this from the factory. We have dual Z screws, so I've never really had a problem with Z sagging on any of my printers, but as the wheels wear, adjustments need to be made, and if they aren't made, you could see some problems on the old style of printer. The addition of dual Z screws prevents that from becoming a major problem. Along with that, the pillars are a completely different profile now. And that actually looks like a good improvement as well, because the original design has the wheels making contact only in one small area on a section of the rail. The new design has far more contact area, which means it should prolong the life of the wheels by quite a bit. One other small improvement is that the Z lead screws also have bearings at the top, which normally will help to prevent issues with Z wobble. In this case, with the other changes combined with these, I'm not sure that it's doing that much, but I think it's a good idea, and it's probably why they moved away from the aluminum top rail to an injection molded piece to have a housing for the bearings as well. Auto bed level, auto Z offset. This is a really nice feature. Again, I never really had any trouble with my other printers in this way, but I never moved them. And they also had glass beds, and these magnetic plates with the aluminum below tend to be slightly warped, and an auto level is needed so that we can get a perfect first layer and prevent any fails. It's just a good addition to any printer, and most of the newest printers have these types of features already. The filament sensor, this is good, though I don't actually use them that often. I usually make sure that I just have enough on the spool before printing. But if you are nearby and want to finish up a spool, that helps quite a bit. I don't really like the idea of letting your prints cool too much, because they can come away from the build plate and then ruin your print if you're using a material that's more prone to warping. But in some particular cases, like if you're using PLA or PETG for example, I think it's probably a good addition, and it will help you every so often to make sure that you can finish a print that you wouldn't have been able to finish otherwise. This printer has Wi-Fi capability, so now you can connect to your printer wirelessly and print over your network or over the cloud as well. And it can also be wirelessly monitored, and those are nice features, and most of the new printers should have this feature. It makes a big difference, so you don't need to watch your printer all the time. Now, this printer does not have a webcam, but it does support one, so that means that you have the ability, if you want to monitor your prints through the video as well. As far as the overall design goes, the top rail is no longer metal. It's now injection molded ABS, which isn't really a big problem, though it does support a fairly large spool of filament for an extended period of time. And if you have the printer in a warm enclosure, it may cause it to sag a little bit and pull those posts. It is pretty stiff, but I think I would prefer to see the spool holder off to one side, or at least the top rail a little bit beefier as well. I like the sleek design. My shop is a bit dusty. It makes keeping this printer clean much easier than the old model, with all the little nooks and crannies that would just fill up with dust. The black color does show dust pretty easily. That's their color, so what are you going to do about it? The bottom is completely closed in, and this is just nice and tidy. If we take the panel off, you can see that it hides all of this mess. And while we're under here, I think it's worth mentioning that for all of the 3D printers these days, the fans aren't usually quiet from stock. I wish they would just pay a little bit more attention to the design of the fan blades so that the printers, at least at idle, are a little bit quieter. And I know that they're trying to minimize the cost on all this stuff, but it seems like if they're able to design an entire 3D printer, they could probably put a little bit more attention into the design of the fan blades at least, to see if they can cut down on some of that noise. I like the touchscreen, but it isn't really a deal breaker for me. Scrolling on the screen with round fingers like I have, it's not always that easy, but you do get there. I have found that I accidentally paused a print because I was trying to get the screen to come back on, except I didn't even realize what I had done, so I thought the print had failed. So now I just leave the screen on. This printer is capable of printing some higher temperature materials, and I agree it is capable as far as the nozzle temperature and the bed temperature. But I can't really recommend doing that without an enclosure. So for this video, we're gonna be sticking to PETG since it can be printed on an open printer like this one. So let's go ahead, load up some filament, and for this test I have some Prusament PETG. It's extremely consistent and should make for a pretty good test. I've already gone ahead and done flow calibration, both the rough flow calibration and the fine flow calibration on this printer, and it turned out that I needed no adjustment whatsoever. And I've also done a pressure advance test for this printer as well, which does make a big difference in the final product. So hopefully those two tests alone will help us to get to some pretty good quality prints. So this print did not turn out quite as well, and I have a feeling that it is related to the calibration of this filament. So I calibrated based off of Galaxy Black Prusament. I did the pressure advance testing, and it ended up being 0.15, which is really high. So this particular filament with the sparkles on it, the Galaxy Black, may be different than this one here, which is just straight orange. So the results are not bad except for when you get to the corner. So inside corners, some outside corners when it's traveling at high speed, and on the inside as well. Actually, I want to take a look on the inside of this just to make sure. It's really hard to see. So I'm just going to heat this up and see how good the inside looks. All right, so the inside actually looks really good on the Galaxy Black. So what I think I'm going to have to do is recalibrate based off of the orange, and the blue may be very similar as well that I have. And then I'll rerun this part again and we'll see if there's any improvement. All right, so I'm having a little bit of an issue with the consistency. I think it should be a little bit better on the 3D prints. So I just took the cover off just to see how tight everything was up here. there's any movement, and it's pretty stiff. Everything is the way it should be. So I don't believe the issues come from up here, possibly the bed. Let me get this back together. Let's check the bed again. At the back, exactly what you'd expect. At the front, there's still a little bit of movement. So what I did is I removed the 2 screws at the front and the 2 screws at the back. So this can then go forward. This can go forward. Take the rods out. So I managed to get the bearing out of the bearing block. In an effort to make sure that this video doesn't go too long, I'm just going to quickly run through all the things that I did to try and get rid of that last little bit of movement in the bed. And this is the final product. There's just a tiny amount of movement here. I had these bushings that I had made on the metal lathe. I tried them. They had way too much friction. I have 2 linear bearings identical to linear bearings in there. I thought I'd swap them out and try them. No difference. Then I 3D printed some bushings. This is ABS and this is polycarbonate. The polycarbonate failed part way up. The ABS worked, but there was too much movement, so they didn't work. So what I did as a final result, as a last resort, I should say, is I inserted little wedge pieces of paper to try and push the rails outward slightly and try and put a little bit of force on the linear bearings. All right, let's go ahead and get some more prints going. Well, I think I figured out what was going on. So I've got Creality Hyper PLA in here, and I'm printing at reasonably high speeds, and I'm getting what looks like good results, finally. For whatever reason, printing PETG cruisement, which is known as high quality filament, on this printer they do not get along. I can't really explain it. It seems to be something to do with the extruder and the way the extruder handles this material. Now, because it could be nozzle temperature related, I have calibrated and recalibrated, and I've done temperature towers as well. And with Hyper PLA, I had good results here. This was a regular speed print. I had good results here. Really good results here. This was an extremely high speed print, up towards 450 millimeters per second at the maximum. And this is Galaxy Black for Prusament, and I had very good results as well. So I'm going to finish that test with the Hyper PLA, but I went ahead and printed the exact same part in the same orientation from the exact same filament on my Creality K1, and I did not calibrate anything whatsoever, and the results so far look pretty good. We'll take a closer look in a minute. I am also using the Bambu Lab X1 Carbon to print the exact same version, same orientation, same print settings, from Galaxy Black PETG as well. So this is the exact same filament, but printed on the Creality K1. And with the exception of a couple little tiny defects, the quality of the print is very good. I'm very happy with this. The overhangs were good. It's pretty consistent. Of course, PETG being shiny does tend to show every single little defect here and there. Now this part here was printed on the Bambu X1 Carbon from the Galaxy Black, and I had a bit of trouble with the overhangs, but aside from that, it turned out really nice. Okay, well that took a lot longer to get to a point where at least I had some confidence with the KE printer. So forgetting about the PETG for a minute, I was able to print and successfully print each time with Hyper PLA on the KE, and the results were pretty good. Unfortunately, that's not the case with the PETG. I had sample after sample. I had pressure advance issues. And after I dealt with those, I had a little bit of over extrusion. And after I dealt with that, I still had issues with the layers, layer alignment. Just a little bit off here and there. Those same issues that I had with the orange, I had identical problems with the blue. I went through the exact same process of calibrating the filament for blue, thinking that that was the issue, but I never came to a perfect final print. There was always something that was going on with it. So let's go ahead, we're gonna head over to the printer and take a look and see if we can figure out while looking inside the extruder. Well, I have no idea if this is gonna work, but I set up a custom G-code to come to the center here, just slightly above the build plate, and do a fair amount of extrusion and then a fair amount of retraction. And then we should be able to see at least what's going on inside here fairly well. Okay, well, that did work, but not for long enough. So I'm gonna go back and adjust the G-code and we'll try it again. Well, I'm not sure what the takeaway from that experiment was. The only thing I noticed was that the teeth seemed to cut into the filament a little bit unevenly. So I have to eat my words right now, but before I do, make sure that you like and subscribe if you are enjoying this type of content, and hit that notification bell as well so you always know when a new video is released. So I thought for sure I was going to see more ghosting, especially at higher speeds. My best guess as to how they've accomplished this is by testing their machines with accelerometers in-house. And since each printer is essentially the same, they've utilized those resulting values for the compensation. Maybe you have some thoughts on whether I'm right or wrong on this, but whatever approach it is that they took, it does seem to work fairly well. Also, I kind of expected to see an extruder on this printer that closely resembled the K1's extruder. It had some issues I know early on, but it's gone through some tweaks and it's actually a pretty nice unit now. This printer's extruder seems to be based off of the Sprite extruder, which I'm not certain is designed specifically for this application. While printing the Galaxy Black with only flow calibration, I had excellent results. And while printing Hyper PLA, I had good results on each of the parts, and I had not calibrated the material at all. I just used the default values in Creality Print. The orange and blue PET G, which is Prusament PET G, and it is dried and it is very precise. I had the same problems on both of them. Even after throwing every single calibration test that I could at each of them, I just can't explain this problem, at least not yet. So I believe the extruder is somewhat to blame for this. It is possible that the extruder and the hot end just are not working well together when it comes to PET G, or at least these two colors of PET G. I've tried adjusting the print temperatures, I've tried adjusting the print speeds, and there just seems to be this strange inconsistency. So I will likely have to make a follow-up video just on the extrusion issue with this printer. The bed rails need to be a little bit more precise. The quality of the rails looks really good and the precision along the length is excellent, but the fit of the mating pieces just is not quite close enough. And I know we're talking about really tiny values here, but it does seem to make a difference, and I would like to see an improvement in this area. So for a bed slinger, it's not bad for PLA. I'd like to see these printers with an option eventually to add LiDAR scanning for auto material calibration, but for now, we're just gonna have to keep on calibrating manually. I feel like this printer, kind of like the older generation of Ender printers, is something that you would buy if you want the challenge of upgrading and learning along the way. If I were just starting out in 3D printing and I wanted to get into printing PLA at a reasonable price, it is an option, but I think we need to get to the bottom of this extrusion issue. So if you've had these problems and have already figured it out, I would really like to hear from you. That said, I hope you enjoyed this video and found it helpful. If I have a follow-up video to explain the extrusion issue, it will be linked up above there. Thanks again to all of my patrons for helping to support this channel and making content like this possible. And take care, everybody. We will see you on the next one.